Okay. So now we're going to also get reminded of all of our exponent laws if we have square roots and cube roots. Do you remember that you can write a square root with an exponent? What's the way that you could write, another way that you could write the square root of x as an exponent? X to the 1/2. And if you had a cube root, it would be x to the 1/3. And so on and so on. So if you had the 5th root of x to the 7, well, the 5th root would be 1/5, and the 7 is still there, so it'll be x to the 7/5. So now we're going to do that same idea. Oh, we're going to have to go quickly back to our powers chart. And I'm going to add 625 on this 5 to the power 4. Because it came up on this one. Okay, so for part A. First of all, we're going to just take the time to change all of our square roots and cube roots to exponents. So I'll rewrite 2 to the x equals 8 times, and this cube root will become 2 to the 1/3. Now looking at our numbers here, can we write everything with the same base? Yes, because you can change 8 to be, first of all, can I do 8 times 2 and write 16? You're going to be tempted to do that. Remember, we talked about this the other day. But order of operations say that you have to do the exponent first. So before you can do 8 times 2, you have to do 2 to the cube root of 2 mental math first. That's not so easy. So we've got to be careful that we don't multiply 8 times 2 and break our order of operations. But 8 is 2 cubed. Now we've got everything with the same base, but we want a single power on both sides of our equation. So what's our exponent rule here? If you've got 2 cubed times 2 to the 1/3, that's where you can add the exponents. What are you going to get if you add 3 plus 1/3? Because 3 is the same as 9 over 3. Plus 1 over 3 would make 10 over 3. And now that you've got a single power with the same base on the same side, again, you might notice that those two have to be the same. So in this case, x would have to be 10/3. Okay, part B. We'll start again by changing all of our square roots, cube roots, etc. to exponents. So we'll have 125 to the 1/2, and that is all to the 2x plus 1 equals 625 to the 1/3. Are both 125 and 625 in the same column? Yeah. 125 is 5 cubed. Notice I'm not trying to do too much at once. Just changing one thing at a time. Because on the left side, we've got a power to a power to a power. Super powerful. Power to a power, we're going to multiply. Again, let's just take this slowly. 3 times 1/2 will be 3/2. 5 to the 4 times 1/3 will be 4/3. On the left side, I still have a power to a power. So I'm going to multiply this through. Three halves times 2 is 3. 3 halves times 1 is 3 halves. And now we finally got a single power on both sides with the same base. Once again, if these are equal, those have to be equal. Subtract 3 halves on both sides. Four thirds minus 3 halves. How do you subtract fractions? Get a common denominator. So it'll be 8/6 minus 9/6. Give you -1/6. Divide by 3 is the same as multiplying by a third. And if you multiply -1/6 by a third, you get -1/18. So these ones are really important to practice, so I'm going to give you guys 10 minutes now to practice those.